Hi, good afternoon and welcome. My name is Anselm Simon. I'm the project manager for the Global Environmental Facility Funded project, Energy Efficiency through Low Carbon Technologies in the refrigeration and air conditioning sector. With me today is Mr. Joachim Nielsen. He's a member of the team from Devcoo, or District Cooling Specialists. Right? District cooling is one of the technologies we plan to feature as part of this project. As the globe continues to warm, we are looking for more energy efficient, clean ways to cool our buildings, our homes, and also the vital items like foods and also medicines. So just to start off our interview, I'd just like to ask Mr. Nielsen to describe the concept of district cooling.
Okay, so district cooling is about making chilled water in a central plant or several. And then distributing that chilled water to a number of buildings for different purposes. But the distribution of the chilled water takes place in underground insulated water pipes. The point of making this centralized and on big scale is that you can make better use of local energy sources and you get economy of scale as compared to the business as usual alternative, which is separate installations for each building and sometimes many installations for each building.
Excellent. So we are more efficient together as opposed to apart.
Correct.
Okay. You mentioned that you could utilize natural sources. What are some of the natural sources that you all would have experienced where you come from in Sweden?
In Sweden we are fortunate. We have an abundance of cooling around us, and we have the four seasons as well that we can make use of in district cooling. But most common source I think is seawater or lake water that is used even in the summer when it's cold enough to produce district cooling.
All right, excellent. Well, we are an island. We are surrounded by seawater, salt water. What are some of the considerations that we might need to take on board if utilizing that as a natural source?
Yeah, I think there are different ways to use seawater. You might think that the water is too hot here to make use for district cooling purposes, but actually there are two options. Either you go deep to find cold water, that's one option. Otherwise you can use surface water as well, but then you cannot use it directly. For district cooling, you have to make a hybrid system, as we call it, where you use the seawater as a cooling source for the chillers, and the chillers then make the proper temperature to distribute to buildings like offices and hospitals and so on.
Okay. So, in terms of the utilization of district cooling, you mentioned hospitals and buildings. Are there any other applications for district cooling? I don't know, like cooling food, produce?
Yeah, it can, in the same way, you can use cooling for refrigeration purposes, but it very much depends on the demanded temperature, if you like.
Okay.
It's very hard or impossible to go sub-zero with district cooling.
So given that we would have systems that are already in place, how easy would it be to incorporate something like district cooling into the existing cooling system, and what might be required generally?
Yeah, generally it's easier to adopt to district cooling if the building that you look at, if that has a centralized cooling system, because then there is one connection point where you could say that you bypass their existing chiller and connect to district cooling instead.
Okay. Given a district cooling installation, let's say as a new investment, what would be the average payback time if I choose to go towards district cooling as opposed to business as usual, several splits or some DX systems?
Yeah, that is a very good question. I'm afraid it's very hard to formulate a standard answer to that. I think the correct answer is it depends very much on the situation.
Okay.
But in each case, district cooling is competing to the business as usual alternative. So for district cooling to happen, it needs to be competitive.
Okay, excellent. So we need to see the tangible results. We need to see the type of savings
I would say so, both in monetary units and in carbon dioxide savings if you have a sustainable system in mind.
Okay. Well, I know Devcoo has experience in Europe and globally. I know that you all would have penetrated certain areas within the region, the Caribbean and Latin America. Do you believe that, the region is uptaking this type of technology quickly?
Yeah, I think where district cooling has bitten, if you like, there it has expanded a lot. In Europe, it started small, maybe 20 years ago, and in some countries there, it has spread widely. In others, not yet. So it's a picture that is not, what would you say, homogeneous. It's very different in different places.
Okay. Well, thank you very much for your insight, Mr. Nielsen. Right, as we move forward towards through the implementation of this project, right, district cooling is just one of the technologies that we're looking at. We're also looking at refrigerant replacement with the utilization of hydrocarbon refrigerants, the implementation of policies and frameworks to support a transition towards more energy efficient, clean cooling, right? So stay tuned as we move through the different phases. We'll be here to provide information and assistance to anyone who is interested in coming on board with the project.
My name is Ronaldo Jalil. I'm the Energy Efficiency Specialist with the Energy Efficiency in the Refrigeration and Air Conditioning Sector project. And I'm here with Mr. Lars Hago from the Devcoo team of foreign consultants assessing the potential for district cooling pilot sites here in Trinidad and Tobago. So we just came back from a site visit at the Natural Gas Company of Trinidad and Tobago, NGC. So Mr. Hago, tell me about your experience at the site visit.
Sure, thanks Ronaldo. I'll be happy to do that. Well, what we learned today at the National Gas Company is that they are using, let's say, natural gas for producing cooling, and that is not that common technology from where we are from in Europe, but it's a conventional technology. Definitely, it's very familiar here in the island.
It's not common, you say.
Now, well, it's absorption technology is normally driven by waste heat as sources. That could be industrial purposes or other heat sources. Natural gas is really not that common to be used for cooling purposes. So that might be the exception comparing to the situation here. I mean, there is a wide range of district cooling system in operation around the globe. And we have to bear in mind that there is, it's not one size fits all technology, because it basically, depending on the type of various sources available, where the actual product is going to be developed. So, but you can see some, standardized technology involved in the district cooling concept. Absorption chillers are quite common, heat pumps, for example, conventional compressor chillers, electrical chillers, but also natural sources like free cooling sources, and that could be from rivers, lakes, or even the ocean.
Trinidad and Tobago is blessed with an abundance of natural gas. We get it at a good rate compared to most other places in the world. And I was wondering, what are your thoughts on the potential for it in the use of chill water system technology, especially for district cooling purposes?
Well, I think we see a good potential for that. Basically, what we learned today is that, and mentioned previously, that this type of centralized system or chilled water system is a necessity to implement district cooling. But a lot of positive things comes with that. Being able to increase efficiency, that means actually reducing amount of primary resources, regardless if that's electricity or natural gas. So I do see good reasons to continuing the assessment of this potential pilot for a district cooling system.
Okay, that's great to hear. Thank you, Lawrence. Look forward to hearing what you have to say at our other site visits coming up soon.
Thanks, Ronaldo.
Okay.
My pleasure.
Okay.